Mike. Thanks, Georgia. I'll just share my screen. Hi, everybody. Welcome along today. So my name's Donal Murtagh, and I work for Basesite Engineering. As per the title of the webinar, I'm going to be talking about accelerating fab delivery with AI through engagement with Basesite. I'm going to start off my first slide, just a quick description of who are Basesite. So we're a semiconductor facility software engineering company. We help build a data foundation that a fab is designed from. So that's utility matrices, tool data, architectural information, pop-outs, any facility scope, anything like that. We help build a data foundation for that. And we also build software that turns that data into a constructible design. In our management team, we've over 70 years combined semiconductor experience, and in every discipline, from mechanical, electrical, bulk chemical, delivery, comms, life safety, and all parts of the schedule. So from layout development to tool install design, utility design, construction, commissioning at the end of it. We've got some details there on some of the projects we have been or are currently involved in at the moment, and some names there from the management team. So I think we like to think we know how the sausage is made with all this stuff, and we have some experience and some know-how to bring to it. The first question is, the title of the webinar is, accelerating design with AI, but why AI? For me, there's three core reasons. The first one is that engineers should be paid to engineer. On almost any project I've ever worked on in semicon, and not just semicon, other industries as well, engineers are talented people. They get paid a lot of money by the clients, and they end up spending a lot of time wrangling vendor data sheets and Excel spreadsheets, disparate bits of information, pulling them apart and putting them back together to get what they want. The second reason is modern fabs are getting more and more complex compared to when I started. It's off the scale, more complex. It's getting to a point where you can't really throw enough bodies at these mountains of data to get a design out of it in a reasonable amount of time. And the last reason is the story. The last reason is in the two figures on the right hand side. So 67,000 estimated semiconductor jobs go unfilled by 2030. Nearly 30,000 of those will be engineering roles. And that's not just, engineering roles worldwide. It's not just engineering roles, semicon. It's semicon within the US, nearly 30,000 jobs. So having automations and things that can bridge that gap to us, they're not really optional extras anymore. They're absolutely needed to get the job done. So having spoke about why, the next slide here is about when we use it and when we don't. On the right-hand side, we're looking at when we don't use AI typically. So AI still hallucinates, as everyone knows. You turn it loose in design, it's going to produce something plausible, but probably wrong. Facilities that are worth billions, small errors early on in the process, they compound through procurement, construction, design, and it's an exponentially larger cost at the end. So we try to avoid those kind of deterministic engineering outputs using AI. Where we find the right place to apply it is, for sure, as a software development side of our business, developing new applications and features for clients in our existing applications. We can do that now in a fraction of the time we used to. It's one of the biggest wins for Basesite, I would say, today. For tasks like summarizing dense project data, very good for that. Obviously, people are probably familiar with that. Cleaning up dirty data, as I spoke about before, you've vendor sheets, you've a partial you've bits of stuff written on envelopes, back of envelopes. We've seen that before. Trying to pull all that together is a big task to do, and the AI can really help speed that up. What I'm actually going to talk about more than any of those is what we term AI adjacent technology. So it's deterministic solvers and optimization algorithms that don't rely on large language models guesswork. So what do we do? How do we do it? It's a three-step process. The first step is getting a good data foundation. That's what lets you move fast. Everyone's familiar with the term rubbish in, rubbish out. No more true than when you're using AI. What we do is we use our application, Facility Connect, to pull together the data we can for the tool demands to start building a utility matrix. Sometimes the client will have a utility matrix, we'll use that, we'll put it in. And when I talk about getting that data foundation together, this is our application, Facility Connect. I've got a fictitious facility here. It's got 50 tools. This scales up to hundreds of tools like any regular decent sized facility. But we've got a tool list here. We've got lots of metadata about the tools, lots of custom fields you can add here, the tool owner, the functional area, the location of the tool, install, deinstall. If I click into one of the tools, you'll see what the meat of what I'm talking about here. So for every tool, we've got all the demand points of connection. So I can see this tool has 5 electrical demand points of connection. It's got a exhaust point of connection demand, and it's also got an air connection, a filtered air connection. And we've got that for all the tools. And the next step then is we take all that information and we take whatever other information you have about design, like the building constraints, engineering constraints, utility equipment templates, and we pull that information into our optimizer that sits within Facility Connect. And what that does is, say for instance, on the electrical side of your design, it'll look at all the electrical demands for every tool within your facility. It will place, for instance, electrical panels at every point possible within that facility. So for a facility of 800, 1,000 tools, it's going to put in maybe 10, 15,000 panels. It will then assign every single tool to every single possible panel within your constraints. So you're going to end up with millions of potential assignments. Then the algorithm gets to work. It starts sorting through all those millions of assignments. And based on the criteria you give it, it will give you back the optimized design for those tools, giving you the facility scope for that optimized design. So what you're seeing here again is the Facility Connect application. This 3D view is generated entirely from the data. Nothing here has been modeled within any modeling software. And what you're looking at here is the tool set of those 50 tools. So those blue cubes are the tools, say, within your fab. The brown and gray boxes, they are the electrical panels that have been placed by the optimizer. So you can see straight away, if I can click into one of those tools, I can see where it's, the panels it's assigned to. Also, straight out of the box, you're going to get load versus time or demand over time information for all those tools. You will have seen when I showed the first page that we had the install and deinstall data for the tools. So the blue line is the tools coming online, their demand coming online. So this is the exhaust system here. And this green dotted line, that's some fans that we've added in to show how this works. So you can see if your blue line crosses your green line here, you're in trouble. And I can see from this that actually we haven't installed a fan here early enough. So you need to either push those tools out or pull that fan in. And that's an example of the kind of feedback you can get from this application and these tools. Final step, you take that optimized design and you hand it over to your AE. So you're giving your AE or your construction trades a head start in design. And what you're going to get is you're going to get reduced scope because it's optimized. You get fewer panels, fewer laterals. We'll talk about that a little more later on. But you're also going to get 100% point of connection pre-assignment, load checked, traceable. Your equipment lists are ready for release for long lead procurement. So if I jump back into the application here, and I can go to maybe mechanical, I look at mechanical distribution, I'll choose that exhaust system again. And here's my exhaust system built out. So it's a very simple system here. It's one main, it's got 5 laterals off that. You can see the fans that you saw in the previous demand over time chart. They're here too. So what this is essentially is an equipment list that can be formatted to any client's needs to say, I'm going to need these 5 laterals. They go in this location. They've got this many points of connection. They're this size. They're this type of material spec. Whatever information you have that can be added in here can be reported out. If I click into one of these laterals, what you can see is down here, I've got all the lateral points of connection on the left. And across here, opposite that, you can see I've got all the tools are already assigned by the optimization feature straight out of the box. So all that work of building out your systems and assigning, that's all ready handled for you. In terms of the result, my next slide here is looking at a case study from a real world facility that we ran the optimizer on. It's a 300 nanometer EMEA greenfield fab. What was interesting about this one for us is that the client had a manual design done already, and they came in and asked us to run the optimizer against that to see what results it would give. So on their electrical tool install system, their manual design was given a requirement of 792 pounds. We ran the optimizer, came out with 534, 32% reduction. Estimating that somewhere around $14.5 million saving. Mechanical laterals for one bulk gas system, the manual design, 80 laterals. We had 57 from the optimizer, 29% reduction, 2.5 million. So that's totaling about $17 million in savings straight off the bat there, going with that scope list. But also out of the box, you're getting 100% pre-assignment, you're getting demand over time reports, you're getting a platform ready-made for you to manage all the pre-assignments for facility loads going forward from this point, because generally your layout isn't the first layout you get isn't the final layout. There'll be changes all along, new tool sets, technologies will come in, things will change, field conditions drive change, and now you have a platform and Facility Connect to manage that change on top of the base design you've already got. And you also have a platform to manage tool install package creation. So if you're dividing up your facility into tool packages that you're handing out to construction trade, you can take those point of connection assignments and you can package them up within Facility Connect and send them out to the trades. But how do you accelerate fab design is the question. 17 million, no one's going to say no to that, but a lot of the clients we deal with, they would say that the pinch point for them isn't money, it's schedule. And my experience, a facility this size, I think this had about 800 to 1,000 tools. A facility that size, to scope out what you're going to need for utilities, it's going to take 10 to 12 weeks for an AE design firm. With the optimizer, you do that in under a day. And that 10 to 12 weeks isn't, just time. You're also dealing with probably 4 or 5 different teams. You have someone doing the mechanical, you have another team looking at electrical, bulk chemical distribution, life safety. And you don't get the final answer until you get all those answers coordinated and pulled together. The optimizer Facility Connect is a one-stop shop, one day. And that leaves you room, obviously, to what if. You have 3 or 4 different layouts, you want to decide on which one, run them all through in a couple of days, compare the answers. And you can go from that point, or even you don't have to decide. You can look at 4 different layouts and look at the commonalities there and say, well, no matter what I do, I'm going to need 300 480 volt distribution panels. I can get them in order now, probably 10 to 12 weeks sooner than I would have done before doing this manually. So the takeaways, AI is for engineers, not instead of them. And AI can deliver real schedule and CapEx savings, accelerating fab delivery. And that is my final slide. Thank you, everybody. I hope I came in around the 10 minutes, Georgia.
You're good.
Yep, that was fantastic. Thank you.
We do have a couple of questions for Donal. So I guess the first one, Donal, is how do you go about getting the data good enough in terms of having instrumentation and data that make sure your system can give the good outputs if the inputs can be questionable sometimes? How do you get that going?
Well, as I said, we do use AI to clean up data, and inherent within the application as well is. Sorry, there's a lot of feedback there on. That's a bit better. Yeah, sorry about that. So within the application as well, there's checks and balances built in to make sure that you can set ranges for data. So if someone tells you that you need a scrubbed exhaust lateral that's 200,000 SCFM, that's wrong. That's not going to work. So a flag will go up and say there's something wrong with this figure here, or a demand on a tool, or anything like that. You can set, I guess the word is kind of sensible ranges for data. We'll throw up flags if we're going out of that, so there's a human within the loop to review and check it, and check that it all makes sense.
Okay. And then the next question for you. When you went from the 792 panels to the 534, did you have to do longer runs on that? Or why do you think the original design was 792?
The original design was 792, I would guess. I used to do this job by hand. I used to get, layouts for clients, and I would have to, decide on what scope went where. And when you're doing it by hand, you will always err to the cautious side. So now 792 compared to 534 is very cautious. But when you start breaking it down and looking in individual areas, if I'm on the fence about whether I need a panel, 1 panel, 2 panel, 3 panels, I'm always going to go for the 3rd panel, because the worst thing I could do for a client is say you don't need a panel, and then it turns out that you do, because that's going to affect the schedule. If there's extra panels that go in and they're not needed, that's less of a problem than not having a panel available at all. And when we had that real world example where we're able to compare the manual design with the optimized design, what we saw is that panels were on average, I think, loaded in the manual design to maybe 30%, whereas when we do the optimized design, it's loaded to 60%. So you can really see that where the optimizer is buying you that reduced scope. Like I said, it's probably not one of those reasons, but it's all those things combined. And the fact that, as I said, these facilities are so complex now, mapping out an electrical system, balancing trains, all that kind of stuff is so complex. It's very hard to do it by hand and impossible to do optimized. You have to err on the side of caution, but the optimizer will take that away from you. It will give you the exact result down to the last point of connection if you want, or you can add some headroom if you want, but the nature of doing it by hand, I think, is what drives that big difference.
Awesome. Thank you. In the name of time, Georgia, I think we need to go to the next one, but I appreciate the insights, Donal. So
thank you.
And